Hey guys, welcome to my channel, and today I'm recording 5070 paper 2 of Cambridge O levels chemistry theory paper. I've already solved so many years, and you can check them out, and I have dropped the link in the description below. You can check it out from there. So without any further ado, let's start May June 2021 paper. This paper is of 1 hour 30 minutes, as it is mentioned over here. Make sure you read all the instructions and then you start solving the paper. So this is part one. I'll be posting more parts of it and I'll put the link in the description below of the playlist for entire May June 2021 papers where you can get all of them together. So let's start with section A. Section A says answer all the questions in this section in the spaces provided. The total mark for this section is 45. Question number 1 says each compound may be used once, more than once, or not at all. Part A says state which compound has a molecule with only 11 atoms. Alright, so if we look at this question, usually if you look at the previous years, questions are somewhat having chemical compounds, elements, everything written, and they are in a list form, in word form. However, in this question, we have it in structure form. Doesn't make a big difference, but you need to just be careful and look at it and solve it according to the question given over here. So basically here you are only supposed to identify, alright, state which compound has a molecule with only 11 atoms. If we look at it, it has 1, 2, 3, 4, 5, 5 atoms. We're talking about atoms of, we're talking about has molecule with only 11 atoms, means we are going to be counting every single atom over here. For example, this makes 1, 2, 3, 4, 5, 6, 7, 8. So this is the answer for sure. Then we have this 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. Not this either. Then 3, 4, 5, 6, 7, 8, 9, 10, 11. C is the right answer. We can easily understand it. So the answer for this is C. Moving on to part 2 is oxidized to form ethanoic acid. Now, ethanoic acid is a carboxylic acid, and since it's ethanoic acid, whenever here the process that we're talking about is oxidation, always remember that we are always going to convert alcohol to carboxylic acid through oxidation. So it must be um, an alcohol with two carbon atoms, which makes it ethanol. So let's go into the options and look at which one is ethanol. And here we have option A is ethanol. Since it has an OH bond and two carbons, so it's going to be A. Moving on to part 3, which says it's an isomer of butene. Isomer we're talking about butene over here. Butene means um four carbon atoms. You need to make sure that we are talking about butenes of four carbon atoms, as well as butene is an alkene. So we'll only have carbon and hydrogen atoms in it, nothing else. Let's go into the options and see. Of course, this cannot be option. It has oxygen too. Oxygen, this one has carbon and hydrogen only, but it's 1, 2, 3, 4. However, this cannot be butene because we only have single bonds over here and all carbons are completely saturated, like they have hydrogens with them, so this cannot be an answer. So 1, 2, 3, 4, 5. So again, this one can also not be the answer. It has four carbon atoms, but if we see here oxygen, right, B can be an option. Why? Because it's in a cyclic form. So yeah, this can be an option. This can be the right answer. Its answer is B. Moving on to part 4, reacts with hydrogen in the presence of catalyst to make an alkane. Part 4 says we need to have something like that in which if we add hydrogen, so it becomes an alkane. So its answer is going to be, of course, we're again talking about alkane over here, so that means carbon and hydrogen only. So this cannot be an option. This cannot be an option. We can look at it. That is D, because we have double carbon bonds over here. If we put a hydrogen over here, so this if we'll react it with hydrogen, that is H2. All right. So one hydrogen, this double bond will break, and a hydrogen will come over here, and one over here. Hence it will be completely saturated as per what I think it is. Yeah, so that's how it's going to happen. Right, so moving on to part 5 contains four different elements chemically combined. Four different elements chemically combined. Elements here we're talking about different elements. Over here we were talking about molecule with total 11 atoms. That means no matter whatever type of atom they were, um, we had to count each one of them. However, over here we are talking about different elements chemically combined, which means we have one, two, we have hydrogen, we have carbon, which makes two, three, three. We have nitrogen 1, hydrogen 2, carbon 3, oxygen 4. So the answer for this is H. And the answer for this was D. Right. So this is how we are going to do this. We are done with question number 1. No, we even have a part B over here. Identify two compounds that have pH of less than 7 in aqueous solution. For less than 7 pH, we have to identify two compounds. Alright. Although it's a 1 marks, but if you only write one compound, you're going to get 0. So you must write two compounds no matter what. Um, since we're talking about less than 7 pH, it must be an acid. And if we look at the acids over here, we have C is an acid. You just look at the question and you'll easily understand that this is acid because it has the carboxylic bond. C double bond O and O. C double bond O OH, which is basically carboxylic bond. And then if we look at it, so none of them, yeah, this two. So since it has this bond with it, alright, and over here this, which gives it the acidic property. So the answer for this is C and F. Alright, make sure you mention both of them. Moving on to part 2, question number 2. Oxygen, sulfur, selenium, tellurium, and polonium are in group 6. State the percentage composition of volume of oxygen in dry air. It's a fact that oxygen is 21% in the air, so you're going to write 21%. Moving on to part B, state one large scale use for oxygen. One large scale use for oxygen. There's so many large scale uses of oxygen. We use it in welding, we use it while cutting metals. You must have studied it in your chemistry classes, so you can write any one of them. I just gave you two examples, that is welding or cutting metals. Alright, so moving on to part C. Two isotopes of polonium are shown. Explain why both isotopes have the same chemical properties. They both have same chemical properties. Why? Alright, it's a very interesting question. Of course, because they have the same electronic structure, which gives them the same chemical properties, since chemical properties are determined by its electronic structure. Alright, then moving on to part 2, give one difference in the atomic structure of these two isotopes. Here we were talking about the electronic structure, and now we are going to talk about the atomic structure. If we see at the atomic structure, so 84 and 209, which basically the neutrons are different, proton is same, but neutrons are different and electrons are same, since I just told you about the electronic structure over here. That gives them the same chemical properties. However, the neutron numbers are different. That means their atomic structure is also going to be different in such a way that this one, polonium, PO210, has one more neutron in it. Moving on to part D, selenium forms a compound that contains only selenium, oxygen, and chlorine. The compound contains 9.6% oxygen by mass, 42.8% chlorine by mass. Calculate the empirical formula of this compound. If we look at the empirical formula, we're supposed to okay, I'll do it in front of you all. We have oxygen, selenium, oxygen, and chlorine. So if we look at the ratio over here, selenium is Se, and then we have oxygen with us, and then we have chlorine with us, Cl. Alright, and if we see, so there contain 96.6% oxygen, 42.8% chlorine. Let's write it over here, 96%, 9.6, sorry, 9.6% oxygen, 42.8% chlorine. Okay, so now there's a twist in the question. We do not have the percentage of selenium, which is not a big deal at all, since we know that if you talk about a percentage, we're talking about 100. Alright, so We are going to add 9.6 and 42.8 and then subtract it with 100 and we'll get 47.6 for selenium. I believe, right. So here we got it. Now, once we are done with this, we're going to check the periodic table and then you will get to know about the masses of it. Since I already remember the mass, let's just continue. So for oxygen, we have 9.6, just divided with 16. Chlorine will be divided by 35.5. You can check it out in the periodic table. And selenium is then 79. So that's all that you had to do. Now you're going to calculate it, and the smallest value will be divided with the complete ratio. So let's calculate it. So it's 1.21 since this is two decimal place, so it will be nice if I put a 0 over here. However, the 0 is not necessary. I'm just doing it since we have one figure as in two decimal places. So it's better to keep all of them, keep the uniformity. And then after you're going to, because 0.6 is the smallest value, you're going to divide everything with 0.6, after which you'll get the answer 1 is to 1, because 0.6 upon 0.6 is 1, 0.6 upon 0.6 again is 1, and 1.21 divided by 0.6 is approximately 2. Yeah, it's 2. Alright, so we've got the empirical formula over here. We have Se, then we have O and Cl 2. Alright. Moving on to question number 2, part E. A sample of oxygen has a volume of 11.5 dm³ at room temperature and pressure. The temperature of the sample is decreased. The pressure remains constant. Describe and explain using kinetic particle theory what happens to the volume of the sample. The volume decreases and the particles move slower. So this is what you're going to write over here, because we're talking about kinetic particle theory as well over here. And we talk about volume both. Although it's a 1 mark, you're going to mention both of the things, that volume decreases and particles move slower. Moving on to part 2, the pressure of a sample is decreased. The temperature remains constant. Describe and explain using kinetic particle theory what happens to the volume of the sample. Um, since here we have decreased the pressure, pressure is inversely proportional to volume, keeping in mind that temperature is the constant over here, is a constant part over here. So volume increases and the particles will move further apart from each other. Moving on to part 3, last part, calculate the mass of oxygen in 11.5 dm³ sample at room temperature and pressure. Give your answer to two significant figures. First of all, you're going to take 11.5, it's in dm³, so we are going to divide 11.5 with 24 since we know it's 24 dm³ pressure at room temperature, and room temperature is already mentioned over here. So the answer for this is, I believe, 0.479. 0.479. After that, you're going to multiply it with the oxygen. This is very basic mole question with pressure involved in it. Oxygen has a mass of 16, I believe. Yeah, 16, right? We just read above. 16. So 0.479 multiplied by 16 and you will get the answer as 15 something. So overall it's 15 grams. Alright. So this is all. Let me mention over here. We're going to multiply it with 16. Why 16? Because oxygen has a AR of 16. So that's it for this video. I hope you found it helpful. In case you have any request, any query, anything, you can put it in the comment box down below. I'll be uploading its further part really soon. Stay tuned, subscribe, ring the bell icon to stay updated with every new video I post. So that's it. Thank you so much for watching and best of luck for your exams.